Hello viewers, in today's class we are going to discuss two problems from differential equations, right? So here the problems belongs to the category of linear differential equation of this type, that is dy over dx plus py is equal to q, right? Okay, so the first problem here is to solve this differential equation y plus 3x square dx over dy is equal to x when the boundary conditions are given as y of 1 is equal to 1. It implies that when x is 1, y is equal to 1, right? So let us start. So here the given differential equation is to be converted in this form. So here we can rewrite this equation as y plus 3x square is equal to x dy over dx, right? And now if we divide both sides by x, then we have dy over dx is equal to y plus 3x square over x, and this can be written as y over x plus 3x, right? Now if we take this term to this side, we have dy over dx plus minus 1 over x, and here we have y, and this is 3x, right? So now we see that this equation is of this form, that is dy over dx plus py is equal to q, right? And if we compare these two equations, we see that p is minus 1 over x and q is equal to 3x, right? So p and q both are functions of x, right? So now we have to solve this linear differential equation by computing its integrating factor. And the integrating factor of any linear differential equation of this type is given by e raised to integral of p dx, right? And here we have e raised to integral of p, that is here we have minus 1 over x dx, and this is simply minus log of x, because the integral of 1 over x is log x, and here we can also write it as log of 1 over x, and this is equal to 1 over x, because here we have used the result that e raised to log ef of x is equal to f of x, right? So now the integrating factor of the given linear differential equation is 1 over x, right? So now the solution is given by y times integrating factor, integral of q times integrating factor dx plus c. C is the constant of integration. So this is the standard solution, or the expression to get the solution of any linear differential equation of this type, whose integrating factor is if, right? So now here we can substitute the values of integrating factor as 1 over x, and integral q is 3x, and integrating factor is 1 over x dx plus c, right? So now this is 1 over y over x, and here x and x get cancelled, so we have 3 times integral of dx plus c. C is the constant of integration, right? And here we have 3x plus c, and this can be written as y is equal to 3x square plus cx, right? So this is the general solution of this linear differential equation, right? So now here we are given the initial conditions as x is equal to 1 when y is 1, So if we take these values over here, we have 1 is equal to 3 times 1 square plus c times 1. So we have 1 is equal to 3 plus c, and c is equal to 1 minus 3, that is minus 2, right? So the value of the constant of integration c is minus 2, and let us substitute it over here. So y is 3x square minus 2x, right? So this is the particular solution of this linear differential equation, right? And viewers, here we see that this equation represents a parabola, right? Because this is quadratic in x, and the solution represents the parabola. Now let us take the second problem. So here we have to solve e raised to minus 2 times square root of x over square root of x minus y over square root of x dx over dy is equal to 1, right? So here we have to find the general solution of this differential equation, right? So let us first simplify this equation by rewriting it, right? So now we can write it as e raised to minus 2 times root x over root x, and here we have y over root x, and taking this dx over dy to this side, so we have dy over dx, right? And now taking this term to this side, so we have e raised to minus 2 times root x over root x, and this is dy over dx plus y over root x, right? And now if we rewrite this equation as dy over dx plus 1 over root x, and here we have y, and this is e raised to minus 2 root x over root x, right? So now we see that this equation, this is similar to this one, right? That is dy over dx plus py is equal to q, right? And if we compare both these equations, we see that the value of p is 1 over root x, and the value of q is e raised to minus 2 root x over root x, right? And now we have to find the integrating factor of this linear differential equation, that is e raised to integral of p dx, right? So now we have e raised to p is 1 over root x, and here we have dx, right? And this can also be written as x raised to minus half dx, and the integral of x raised to minus half is given by x raised to half over half, right? And this is e raised to 2 times square root of x. So this is the integrating factor of the given differential equation, right? Now the solution of this equation is given by y times integrating factor is equal to integral of q times integrating factor dx plus c. So this is the standard form of the solution. So we have y times integrating factor is e raised to 2 times square root of x, and here we have q, and q is e raised to minus 2 root x over root x, and integrating factor is e raised to 2 root x and dx plus c, right? So now we have y times e raised to 2 root x, and integral here this term and this term get cancelled, so we have 1 over root x dx plus c, right? And this can be written as e raised to 2 root x, and here we have the integral of 1 over root x as x raised to minus half dx, that is x raised to minus half over half, that is here we have plus sign, so x raised to half over half, that is 2 times square root of x, right? So here we have 2 times of square root of x plus c, and this expression can also be written as 2 root x uh, times e raised to minus 2 root x plus c times e raised to minus 2 root x. That is dividing both sides by e raised to 2 times of square root of x, right? So viewers, the general solution of this differential equation is given by this expression, right?